Howdy, folks. Good to see you. How's everything? Jack Schmidt.
Ladies and gentlemen, this guy has hats of many kinds. He's a doctor, he's an astronaut, he's a senator of the United States, he's an executive. He was born in Santa Rita, New Mexico, and reared in Silver City, New Mexico. He went to school. He got his Bachelor of Science degree in the California Institute of Technology. He spent about a year in Oslo at the university there studying for his graduate degree, and then also he ended up getting his doctorate in geology from Harvard, which is one of the best schools in the United States, I think. He went to flight school at the Williams Air Force Base in Arizona, 2,100 hours in planes, 1,600 hours in jets. Something else, huh, folks? They selected him to be an astronaut in 1965, and by the way, he holds the only title that the Apollo astronauts have: scientist astronaut. Only one, right there. And he spent about 301 hours on the moon, over 22 hours doing EVAs on the moon. He was the backup guy for Jim Irwin on the Lunar command module for Apollo 15, in case you want to know who he was backup guy for that. And in a moment, he's going to come here and take over as soon as he gets through there. You know what I'm talking about? Harrison Smith. That's his name. Hi, sir.
Thank you.
Let's give him a hand, too. Where's my master guy? Oh, okay. I think they want him down there, too. Sir, I think they might want you down there, too. Where? Pictures? All right.
I'll be right back.
Now, when they climb on board, I want to give a hand for Mr. Comerford and Harrison Smith. Would you clap for both of them, folks? Here they come. Give them a big hand, folks. Harrison Smith and Mr. Comerford. Now, sir, if you would please take over.
I will.
I'll take over.
All of you know where we are, right? Pad 34. You've heard about Pad 34. It was, of course, the scene of the unfortunate and tragic loss of Gus Grissom and his crew. But many people, including myself, on reflection, think that sacrifice really made it possible to meet John Kennedy's goal. Because even though NASA had pretty worked out how to manage the Apollo program by that time, that accident focused attention on the one or two things that were left to fix. And one of them had to do with much more careful management of the way the command module was outfitted. And also some of the materials that were put into the command module that were flammable. One of those materials turned out to be glycol. And so they had to revise the plumbing as well as the nature of the material they put in there for cooling. And a lot of other things. But the net result of the accident was to bring George Low into a position as Apollo spacecraft program manager at Houston. And Low was absolutely the perfect person for that job. And he assigned none other than Frank Borman to be his eyes and ears and basically on-site manager at the North American Rockwell, as it was called then, when they were building the command module. And the net result of that team, and of course everybody else who was supporting them, Aaron Cohen and people of that stature, was that we ended up flying a nearly perfect command module with Apollo 7. A few minor things, but it was ready to go, and it meant that Low's plan, which he envisioned actually in August of '68, and planned to take the second flight of a Apollo command module around the moon, could go forward. The reason for that plan coming up is that the lunar module being built by the Grumman Corporation, Aircraft Corporation in Bethpage, New York, that had fallen behind schedule, and so that we needed to do some things to keep the momentum of the program going. And Lowe proposed, and successfully proposed, that if Apollo 7 was successful, that in December of 1968 we would take the command module, the next command module, with Frank Borman and Jim Lovell and Bill Anders aboard around the moon, and to actually not only take it around the moon but put it in lunar orbit. That meant that we were going to work out everything that had to do with a flight to the moon except landing in that period of time, and that was done within 4 months. The concept was sold, and we went forward with that in 4 months. Remarkable what people were able to do in those days, and in that context, from December of November really of 1968 to November of 1969, we launched an Apollo mission. Most of them, all but one of them, was Saturn V's, every 2 months. And then, of course, the program slowed down a bit, and then a lot with Apollo 13. Jim Lovell's on one of the other buses, and he can tell you a lot more about 13 than I can. Although, when I had just been assigned to the backup crew of Apollo 15, the reason for our celebration here today, and I was down here at the Kennedy Space Center using the simulators, because everybody else had gone to Houston, and I figured I could get a lot of simulator time since with the launch of Apollo 13, people down here were looking for things to do, and so I let them do a lot of training for me. But when the explosion occurred on the Apollo 13 spacecraft, we immediately, we being the simulator engineers and myself, began to work on the procedures necessary in order to bring them back. Not only developing some of the navigation procedures, but testing the procedures that were being finalized in Houston. So this whole thing carries an awful lot of memories for me, and I know for the rest of the astronauts that are on the other buses. Now with that, I'd be happy to answer any questions that you might have as briefly as I can, and get a lot of questions. Any questions? Way back there.
What did it feel like to walk on the moon?
What did it feel like to walk on the moon? That gentleman's from Roswell, New Mexico, and along with his friend. It's a great part of the state that I'm from. That's something that's extremely hard to let you know. I can talk to you about the physical feeling and what it looked like and things like that, which I will, but the emotional side of it is like almost anything else that you do that is truly one of the meaningful experiences of your life. You have to be there. You have to do it. And I don't know how many of you have walked up to the rim of the Grand Canyon for the first time. Some of you I know have had your first child, either second, third, and fourth. Those are those kind of experiences in life that really are meaningful, but they're significant, because no matter how much people tell you about them, you're going to have to experience them for yourself. Now, with respect to the Apollo 17 mission, we landed in a valley on the moon called the Valley of Taurus Littrow. It was a deep, long mountain valley that radiates from one of the large lunar basins, a basin that's almost 500 miles in diameter. It was formed, when that basin formed, by a series of faults. But it is a valley deeper than the Grand Canyon. The mountains on either side rise to 7,000 feet. It is narrow. It's only about 4.5 miles wide at its narrowest point where we landed. It is illuminated during the day at least, by a brilliant sun, as you might expect. But the thing that I found hardest to get used to, and probably never got used to, is that in spite of that bright sun, the sky's black. It's absolutely black. Of course, here the sun's out, it's blue. But there's no atmosphere around the moon, and so we get no color from that sky. The maybe even more impressive to me was that anytime you wanted to, you could look up over the southwestern mountains and see this beautiful blue planet Earth, blue and white planet Earth, hanging over that mountain. And anytime you're on the moon, the Earth stays roughly in the same part of the moon all day, the same part of the sky all day and all night. Because the moon is always keeping one face towards the Earth. That means wherever you are on the Earth, it's in a different, on the moon, the Earth is in a different place, but it always stays there. So if you were right in the center point of the moon, the Earth would be directly above you all the time, and if you're at the horizon on the moon, or the edge of the moon as we see it, the Earth's going to be right down on the horizon. So anytime you see a picture of the moon, and there's some wallpaper around that you can buy, or used to be able to buy, that shows us working in the Valley of Taurus Littoral, but it also shows the moon, or the Earth, just above the horizon. Well, of course, that's totally inconsistent. Somebody just stuck the Earth in that picture. It also, people do strange things. It also, they changed the shadow line, the terminator of the Earth, on that picture, and I never figured that one out either. The worst use of the picture of the Earth that I took, that's a full Earth with the continent of Africa in view. You've all, I think, seen that. I took that from 34,000 miles away on the way to the moon. The worst use of it, though, was I remember being on an airplane many years ago. TWA was still an active airline. Their onboard magazine had that picture in it, and they decided that the Indian Ocean looked a little empty, so they had moved Australia over into the Indian Ocean. Photoshop, I don't think had been invented by that time, but they figured out some way to do it. Any other questions? Yes?
Were any of the experiments on the moon, did any of it involve searching for water?
Any experiments on the moon involve searching for water. Our field exploration on the moon, and I'm a field geologist, was designed to look for anything unusual. And so if we had found any water, we probably would have noticed it. Of course, we sampled extensively, and when we brought those samples back, particularly the debris, the samples of the debris that covers the moon, we call that regolith. If you want to one-up your friends when you get out of here and ask them what the geological name for the debris layer on the moon is, it's regolith. When the community analyzed those, we found that they contain significant amounts of hydrogen that is derived from the particles that come from the sun called protons. When protons impact the moon, they collect an electron, they become hydrogen. That's what hydrogen is. It's a proton with an electron going around. And that hydrogen, of course, when you heat up the regolith to, say, maybe 1,000 degrees Fahrenheit, it will react with the oxygen in the minerals and produce water. And so you can make water anywhere on the moon if you just heat up this regolith. We now know, though, that there's apparently significant water ice at the poles, and that was discovered by the spacecraft that is actually currently in orbit around the moon, called the Lunar Reconnaissance Orbiter, and an impactor that it sent down to the surface that hit inside one of the craters at the poles that has permanent shadow. And that permanent shadow at the poles of the moon has a temperature just 40 degrees above absolute zero. It is really cold. And in those craters, there appears now to be a significant amount of water ice, as well as probably some other volatile material. Now, we don't know exactly the origin of that ice. It may have come from the impact of comets on the surface, with some of the water in comets ending up in these permanently shadowed, very cold places. Or it may have come from the interior of the moon over millions of years and just accumulated there over time. And until you can actually get a sample of that and look at the isotopic composition, we really won't have an answer to that question. Yes?
In your experience, which was tougher, going to the moon or serving in the Senate?
In my experience, which is tougher, going to the moon or serving in the Senate? Well, let me give you the difference. Going to the moon, we were dealing with a very large number of people dedicated to a specific goal and doing that and meeting that goal successfully. Working in the Senate, that wasn't quite the case. It was an interesting transition to realize that you're working with people who have their own political, largely, not entirely, their own political interests in mind. Now, things have changed even since I was there. I left the Senate involuntarily in 1982, or January of '83. At that time, up to that time, there were some of the old hands in the Senate, both Democrat and Republican, and really would have to call them true gentlemen. And they seemed to all have the interests of the country as much in mind as they did their own political interests. I don't sense that now. If I were there now, I think it would be the rare person that was thinking in those terms as much as it was when I was there. And I shouldn't say I'm a Republican, so full disclosure, but it was particularly noticeable, I think, in the other party. The gentlemen I remember as working with and being very easy to work with were the older Southern Democrats. And not just the Southern Democrats. I was there when Hubert Humphrey was there, Scoop Jackson of Washington. And these people, you really had the feeling that although you might disagree on some things, that everybody was, these at least, were trying to work for the best interest of the country. I'm not quite so convinced of that right now. Yes, sir.
After 40 years of the Apollo missions, are you disappointed we don't have a colony on the moon?
Am I disappointed that we don't have a colony on the moon after 40 years? Well, I am. I was disappointed when I realized that NASA had stopped flying Saturn V's and spacecraft to send to the moon. That actually, I've just discovered really recently. I'm doing a fair amount of research on this. That decision that basically countermanded the Eisenhower-Kennedy decisions to build the Saturn V, and ultimately to take Kennedy's time to challenge the country to go to the moon. That decision to stop doing that began in the Johnson administration in 1968 and was confirmed by the Nixon administration. So just in that short period of time, we made the decision to not amortize, to not use the investment that we put into Apollo. There are a lot of people who were complicit in that decision, including NASA manager. But I think historically now you can pretty say that it was a major error. It really began the gradual decline of national space policy. Now, that doesn't mean the space shuttle wasn't a magnificent accomplishment, and finally, after many fits and starts, the space station isn't a magnificent accomplishment. But we abandoned deep space, and from a national geopolitical point of view, that was a mistake. And with the Saturn V, had we maintained that assembly line in some maintenance mode, then we would still have that kind of capability to go into deep space and would have been able to use it way back there. Yes? Can somebody repeat the question? I got something about blowing up. Apollo 1, yeah, the 204 spacecraft fire. That was a combination of circumstances where we were moving much faster than we should have, and where all the things we knew that should be fixed in that spacecraft had not been fixed, including the removable of flammable materials. And somehow or another, an electrical short, probably an electrical short, triggered a fire, and the hatch at that time, the spacecraft hatch, was not designed for a quick egress. After the fire, it was. And in fact, when I was in the spacecraft during launch and other times, I was responsible for making sure that hatch was ready for quick egress, and we made sure that it was. But also by the time I flew, and certainly by the time Apollo 8 flew, the spacecraft was really what we call a Block 2 spacecraft. It was really those kinds of issues had disappeared. Yes. By the way, if anybody has any questions, we just went by the vehicle assembly building. That at the time it was built was the largest enclosed space in the world, and that later has been superseded, I know, by the Mall of America in Minneapolis. And I understand the new Boeing assembly plant for the 787 is bigger in terms of enclosed space, but it was a magnificent capability. And one reason it's so big, and if you look carefully, you see, as you go around it, you'll see 4 of these very extremely high multiple doors. Well, when the Apollo program was conceived, initially under Eisenhower and then consummated by Kennedy, it was thought that we would be launching Saturn V's much more frequently than even I described, and so it was built to handle the assembly of 4 Saturn V's simultaneously. And now, has it been utilized fully? Almost. I mean, particularly the way it was redesigned to handle the shuttle. Most of that interior space has been very useful to us, and hopefully will be useful to us again in the future. It's a remarkable building, and I remember when the first time I was taken there as a young astronaut, we went inside and they told us, look up, and there were clouds at the top of this. It would look like clouds, but there was mist at the top of the building. I'd never been in a building that big. It's those kind of things you sort of remember from your experiences. Yes?
As a person who walked on the moon and served in the Senate, I mean, that has to be one of the most accomplished individuals ever to walk the face of this earth. What can you tell about my children today? What can you tell kids that are 9 and 10, 8 and 9 to inspire them to get there? So,
well, may I add one more thing?
Go ahead.
I was the only geologist who walked.
I'm the only geologist.
So I sort of fit into it. I'm very proud of the category and honored to have been in that category. The only thing that I can really recommend is that you have to be prepared to take advantage of luck. And we all go through life that way. And the degree to which we can take advantage, let's call it, of opportunity, some people call that luck, is to be prepared to do that. And that preparation starts with as broad and as complete an education as you possibly can have. And I was fortunate in many ways with my family, primarily, insisting, and I guess I was willing to get as good an education as my brain could allow me to get. And that's, be the best that you can be, and that's what you have to do. Otherwise, if opportunities come along, you either won't recognize them or you won't have the confidence to take advantage of them when they do appear. So education is absolutely fundamental. And if I had to pick one major long-term issue we have to deal with in this country, it's the vast improvement of this education system that we've allowed to get away from us. And that's something somewhat different than what we're after today, but it underlies, I think, almost all of our problems. The question of how we deal with that fundamental deterioration of our education system. Now, we're approaching Pad 39A, And all of the missions to the moon went out of this particular location. It is not as quite as impressive as it was for Saturn V. Imagine that launch structure being what, about twice as high for the Saturn? About twice as high for the Saturn. This is the shuttle related launch structure.
300 feet tall.
Yeah, this including the mast? No, to the top of the mast is 380 feet. At the top of the Apollo structure was 400 and something, I believe, 402 or something like that. And one of the things I remember coming out here when we came out for the launch, every other time we'd been out at the launch pad, there were people, hundreds of people moving around doing things like that. When we came out to launch on December 6, 1972, they dropped us off at the base of this huge tower, the launch tower, and there wasn't anybody there. Nobody. And the three of us were standing there, expected to get in the elevator and go up. And the only people on the launch pad at that time were the people up in what we call the White Room, up at the top, that were going to help strap us into the spacecraft. That was Hunter Brent and his crew. But to stand on that launch pad with nobody else around is another one of those experiences that I didn't expect to have. We also, for that phase of Apollo, we had a escape cage in case there was a fire or we had to get off the launch pad for some reason in a hurry. At a certain phase of the mission, we would we would run out of the spacecraft, get out of the spacecraft, open the hatch, get out of the spacecraft, run down in our suits to this cage, and the White Room crew would join us there, and then we would go on a long slide wire, you can see a wire there, something like that, down and get into a big bunker. And we tested that out for Apollo 17. Some of the other guys didn't, but we did. And that was quite an experience as well, to ride that cage down from about 400 feet up in the air. The tower on the right, it looks like a big water tank, is indeed a big water tank. I believe 400,000 gallons of water. And that is water that is just before any launch goes into a spray system for the launch tower, as well as a cooling system or a noise suppression system, actually, in the big diverters, flame diverters. It's primarily for both purposes, both cooling of material, but also for noise suppression. And it does a very effective job, even though it sounds awfully loud if you've seen a launch.
Well, sit down, sir. Made room for you.
Well, that's right.
This part where that suppression.
Now let's see. This is
That's the change-out room right there, sir.
That's what?
The change-out room right there.
This is change out. Oh, you mean up there? Yeah, up on the pad, the shell that's facing us. That's a shell that goes over the payload bay of the shuttle. I was thinking of this tank right here. Is that the?
That's oxidized methanol.
Oh, that's a hypergolic. That's right. Hypergolic tanks. Hypergolic fuels are fuels, usually hydrazine and nitrous oxide. That if you put them together, they're going to ignite. And we use those for reaction control systems and rockets on the spacecraft. In the shuttle, it was used both for that and also to run the APUs, I believe, the auxiliary power units on the shuttle. Now over here, I believe that's is that the hydrogen tank? The big white tank over there is for liquid hydrogen, and then there's a liquid oxygen tank way over there, right? That the oxygen.
We always see
Oh, it's around on the other side. Okay. Well, that's I'm looking at Pad B. Pad B is being demolished, I guess, right?
No, be modified.
Modified? For what?
For future commercial use.
Oh, that's all that's. Okay. Well, if we ever see that. What's that? Oh yeah, you see the stacks there? They're telling me that those are flare stacks for burn off of the excess hydrogen that is vented from the spacecraft.
Those white things beneath the bed, sir, are filled with helium nitrogen for purging the lines so they fall in the bed.
Oh yeah, you see the narrow tanks underneath the launch pad there?
Right.
We'll see them a little better here in a minute. That's helium that's used to purge the various lines. I guess particularly before fueling starts, just to try to make sure everything's cleaned out of it.
Are these your mailboxes?
Everybody know what's right in front of us here on the side? Those are cameras. And I guess those are entirely NASA cameras, right?
Yes, sir.
And the outside the gate, the media is allowed to set up cameras, right? Outside the fence.
Yeah, they protect you so they won't be damaged.
Now, when I was down here for STS-135, the Atlantis launch, all of this area in here, right after the launch, was brown. Because it, well, now wait a minute, it would be out ahead of the, yeah, is it still brown? Yeah, I thought I remember this was brown too. Of course, we haven't had much rain. Maybe you've had some rain since. Yeah, it's going to be a little brown, but it's also greening up pretty fast. What's that? Somebody asked? Sing out your questions. We've got a bunch of experts here. Not me, but...
What are the train tracks?
Oh,
Good question. I don't think they're on this first.
No, I think... I'm not sure. Unless it was... originally they were bringing in the hydrogen by tank car. And oxygen by tank car. And they just never have taken them out. I don't think they're used now. As we came out here and I was chatting away, you probably noticed the gravel, big gravel road on the side of the road we were on. And we'll see that again here in a minute. That's a river gravel roadbed for the transporter crawler that brings the rocket and spacecraft out to the launch pad. We'll see that. I think we'll go by the transporter crawler. We did go by one, and I was chatting away.
Oh, we should.
Well, there are two. There's one that hadn't been used in a long time, and I think is over by the VA.
We knocked down this fence on Mark. Yeah, we knocked down this fence on one of Mark Kelly's launches. The power of that launch was so powerful. It knocked out about how many was it? 3,500 bricks or something like that came loose, and knocked down the fence. We had to get it all fixed, and then they replaced it with fondue fire, I believe it was, wasn't it? Which is heat-proof concrete. They got that all repaired. But
up until that time, it was still being followed.
yeah,
Original bricks.
it was the original bricks from the Apollo days, and then they changed it all because of that powerful launch that we had. Mark Kelly was married to Gabriel Giffords, and I'm sure you know who she is, sir.
Oh, yeah.
And
She still is married.
yeah, she is married to him. We almost lost her, almost. Thank goodness. Now, this is the opening of the flame chute right here, of the flame trench. Fire chute's out there about, I'd say, probably 600 feet, 3,600 miles per hour, probably, what would you say, about 6,000 degrees, something like that? 3,600 degrees? 4 to 6, something like that?
About 165 decibels.
So about 165 decibels, that'll knock you out, kill you. And you can see right here to the north, see the whole faces north. Well, this is north to your right. And it looks a lot better than it did because at one time, right in this area right here, it was nothing but... See to the right how it's all dead kind of over there from all the steam, where the foliage is? That's Pad B over there where you see all those towers. They're modifying it for the future. We launched Apollo 10 over there and all the rest right here. Matter of fact, everybody that walked on the moon that was launched right here, including you, sir. That was on December 7th, wasn't it? 19, here was it? 72.
We barely made December 7th Florida time. Everywhere else was December 6th. We had a 2-hour and 40-minute delay, and those of you that were paying attention to the Atlantis launch, you notice they got to 31 seconds and there was a hold.
Right.
Well, we got to 30 seconds and we had a hold. And it only took them a few minutes to work out their problem. It took ours about 2 hours and 40 minutes. Actually, it only took about 5 minutes for the crew, the launch crew, to figure out what was wrong. We had a computer that thought it had not pressurized an oxygen tank in the third stage rocket, the S4B. And it turns out that that tank had been pressurized by a controller in the launch control center when he saw that the computer had not done it. But the computer did not know that it had been pressurized because it was looking at whether a signal had been sent to pressurize it rather than whether it was really pressurized. Just one of those little things that somewhere in the deep dark ages of programming was put in there, and you can't figure out why in the world it was done that way, but that's what held us up. And in those days, you could fix a problem like that just with a wire. You could go into the computer and put a shunt around that signal. And that's what they did. And today you'd have to go in there and somehow reprogram it, which you probably could do it fairly quickly. Yes, sir?
So what does it feel like when you're sitting on top of a Saturn V and it cranks up?
What does it feel like when you sit on top of a Saturn V when it cranks up? The main, before we get to that, hold that question.
Okay.
One thing you can see here is the neck down to increase the velocity of the water going in. You see that from the tower, the tank's neck down, you get a higher flow rate into the flame trench. You know, this grass has greened up a lot since STS-135 launch. It's you can already tell it happened. Well, it was completely brown when we were here a couple weeks ago.
Water makes all the difference in the world.
Yeah, it does. In New Mexico, that would have stayed brown the rest of the year. If it wasn't brown all year anyway.
Right here, the opening stages on the far there, the big
Oh yeah.
big steel structure that sits on these posts.
And the shuttle sits on the platform they drive out here on the crawler, stick it on, park it here, and crawl it.
This is the north end. I found to shoot out this way.
Yeah, this is the both the S4B and the main engines with both the boost the solid rocket boosters and the main engines come out this way. The main engines that way and the solid rocket boosters out this way.
Okay, hold on for a second so we can take pictures.
For y'all, there wasn't the flame reflector was not in there.
Yeah. Now you see those lines going off the top, what, the 6 of them? Yeah, 7 of them. Those are the escape lines. Now the shuttle will go by in a minute. You'll see how the shuttle handled that escape. Different than ours.
Yeah, the escape system is set up with 7 baskets because you can put 2 people in each basket. We have a closeout crew that would strap the crew into the shuttle, so we had to have enough room for all of them. That was only for a pad emergency. That's not a flight abort. That's only if we had like a fire or something on the pad, or we had something happen out here, toxins were released, and this crew could escape down those down that basket system.
About 23 seconds or something like that.
Yeah, it travels about 55 miles per hour. The baskets are situated at the 195-foot level, which is where the crew entrance is, and so it's it did the math. About 55 miles per hour, you land in a like Harrison said, you'll see over here the sand and the chains and the bungee cords and the nets that stopped them. High-tech braking systems. The biggest difference, the Apollo pad was kind of a clean pad concept. We didn't have the structures under the fixed service structure, the rotating service structure. All that was on top of a mobile launch platform for the Apollo Saturn V program. Once we got the shuttle, we decided to build the structures out here like it is now. And in fact, the fixed service structure, which is the tallest part, I believe it's the top 2 levels, or the top 2 sections, are the old Apollo Saturn V gantry. Okay, they utilize that for this fixed service structure.
I don't want him to
What are you pointing at?
Well, the cables where the baskets stop, and you get out.
Well, this picture he has here, he can maybe show you later, is of Gene Cernan. I took it. It was early in, just after we had checked out the Lunar rover. And you can always tell the commanders in an Apollo picture, because they insisted on having a red stripe on their helmet and on their sleeves. So that's the best way to tell. Okay, but I took the picture. No, and the first EVA, I actually had black and white film in the camera I used during most of the time. But in the first EVA, we traded the camera back and forth to get the PAO shots. Now let's make sure that we everybody sees this is the LOX tank.
Yeah. Yep.
Yeah, this is the LOX liquid oxygen tank.
The other one is
We passed that. It's on the other side. Yeah.
right there. That side should be the front side. That's the fuel side. They're both out there backwards.
What did you say the start level of this escape system was? 195? So ours was 3? No, 290. 290. Now the nets, you see the nets here, and there's some change that will be picked up, so that, and then would they evacuate into the bunker from there? Yeah.
That's where they slide down. That was the escape.
Now, if you look way just below the top tower there, that's a lightning arrestor, right? Yeah. You'll see what looks like a cone-shaped cap with a red line coming off of it. That's the cap that would stay on the external tank until just before launch. And I believe that's the it's an oxygen vent, but I believe that's the arm that the computer didn't know had retracted and delayed the Atlantis launch that 2 or 3 minutes. And if I heard correctly, during that period, they just put a camera on it and verified that it had retracted, and they were good to go.
Sir, there also you can see if you look to your left, you can also see the trucks that make the whole structure move around a railroad track, and you see the yellow cabin. That's an 8-wheel truck on Reach Lake. And so that moves around, and they wind that back before the launch, about 19 hours before the launch, to expose the shuttle for liftoff. And then that yellow cabin up there is where the driver sits to do that maneuver. And there's some xenon lights up there to keep everything real lit up at nighttime. And is this the truck side building right here? Okay, this one right here? Or the monument harvesting? Okay. All right. This is part of the hypergolic fuel system right here. That's what they use in the reaction control system in space, so they can maneuver up there. Because they take their own oxidizer with them, so they can make some maneuvers. There's 6 camera mounts on the pad. There's one right here also. There's more cameras. We used to have around 12 or 13 cameras on each one of them back in the old days, but now with these new digital cameras that NASA's developed, maybe you use 7 of them. The digital cameras are so superior to the old ones that we don't use as many. You did a good job on this here. Anytime you want this, Mr. Smith.
No, that's right. Now, we're going to cross over the gravel roadbed that the transporter crawler used and then to get up to the launch pad. And when it hits this change in slope, it actually begins to adjust, so the rocket is always kept level. It has a hydraulic adjustment. So the rocket stays vertical, stays vertical, even though it's going up that slope. They tried a large number of different materials for that transporter crawler before they finally, in testing, realized that the river gravel, the large coarse river gravel, was best to adjust to the weight of that transporter crawler. Anybody here knows that weight? Just sing out. I forgot now, but it's huge. Yeah, the crawler. 6 million pounds. 6 million pounds, and each of the treads that you'll see on the way out is about a ton, about 2,000 pounds. Yeah.
Was it the same crawler used for the Saturn V?
Yes, the same crawler was used for the Saturn V. It was built by a large equipment construction firm in Ohio, I believe, and but it was based on what had been used technologically in the Iron Range, I believe, up in Minnesota. Variant power, that's it. Yeah.
Were you ever in the river?
Oh yeah, yeah. I believe the Apollo cage went directly into the river. Yeah, I think so.
That'd be interesting.
Yeah.
Now these river rocks come from Tennessee River.
Tennessee River rock. Now and it's probably rock that was brought down from Canada by the glaciers. Yes, sir.
Earlier on the bus, they were telling us, the other gentleman was telling us about the future system, which might be a bigger rocket, which weighs more, for the Orion capsule. And I was just curious, would they be able to use the same crawler for that? Or would the new system be too heavy for the current crawler?
Well, I do not know the details of the plans for a new heavy lift launch vehicle. My guess is that the crawler was over-designed to begin with, and it probably can handle it, but I just don't know. And that program has unfortunately been subject to quite a few delays. Even though it's been funded by the Congress, the administration seems to be diverting those funds into Florida, where the essential work has to be done eventually, but not right now. The main design of that rocket has to be done in Huntsville. And just because Florida may be more in play in the next election, don't think that that's why the money is coming to Florida. Now, you had a question earlier. Oh, what did it feel like on top of the rocket? When the Saturn, now the shuttle gets off the launch pad in a hurry. It accelerates, those solid rocket boosters take it up there very fast. The Saturn rocket did not move nearly as fast. It took 14 seconds for the base of the rocket to go the height of the tower. And so it was very slow acceleration, but when the 5 F1 engines that you'll see in the Saturn facility here, when they ignite, they're very rough. It's a kerosene oxygen system, and they do a wonderful job. Did a wonderful job, but they're very rough burning. And so you had this very heavy, low frequency vibration, and that's the first thing you feel when they ignite, is the vibration. And the rocket actually is held for almost 9 seconds while they come up to thrust. so the rocket's vibrating very hard at that point. Then it lets go and the vibration continues, and then you gradually start to feel the increase in G's. And the first thing I thought of when that vibration started is, why did we go through all the launch simulations where the crew is sitting there looking at their gauges and they're, it's all quiet, and you're trying to see what kind of problems the simulation supervisor is going to throw at you, and of course in the real world you can't read those gauges. Not until you get off that first stage. Okay, and then we have another question that I ignored for a minute. Make sure we look at that problem. Sure.
Weren't you primarily the person taught how to navigate on the moon, about the way it's structured and everything?
Well, I was deeply involved in developing some of the techniques for precision navigation on the moon, and Jim Lovell and I worked together on Apollo 8 to test out those techniques, which were called landmark sighting, and it was a way in which you could use the navigation sextant, which was really a 60-power telescope, in the command module to sight on features on the lunar surface that, through various photographic techniques and geometric techniques, had been positioned relative to the center of mass of the moon, which is the important feature for navigation around the moon. And if you can get a precise measurement of your spacecraft's position and movement relative to one of those spots or several of those spots, then you can define your spacecraft's position in space relative to the center mass of the moon. And that really was one of the major ways in which we were able to land within a few tens of meters of where we planned to land anytime we went to the moon. Only Apollo 11 had difficulty with that, and Apollo 11's difficulty was because we hadn't really been able to map out the gravitational field associated with what are called mass concentrations, mascons in the moon. Okay.
So we're going to go there.
Okay, the crawler's been moved? Huh?
It's in front of Highway 2.
Oh, there you go. Well, you can see fresh tracks, so it must have been moved.
Just brought the MLP back from 135, so you can see inside.
Oh, yeah. MLP is the mobile launch platform.
No, there's the cancel. They're actually testing the crawler right now.
You'll see the crawler sitting in front of the what is high bay number 2 of the VAB. Right now what they're doing is they're doing some testing for future use. They're checking to see what the weight distribution are, going over the threshold of the vehicle assembly building, and also the thresholds of the roads to see what the weight distribution is, so they can figure out just how much weight they can utilize the crawler transporter.
The crawler is the one with the yellow tracks right there.
A lot of the hardware we use for Shuttle was derived from the Apollo Saturn V program, the mobile launch platform, which we built the Shuttle on top of, which we also built the Saturn V on. The crawler transporter, both the LC-39A and B, the vehicle assembly building. Let's see what else. That's about it. But pretty much all of that hardware, that ground support equipment, was used for Shuttle, and will be used for some of the future programs too. Not all of it, but some of it. The tower that you see off kind of forward of us, and it'll be to our left as we go by it, that's what we call the new ML, the new mobile launcher. We're going back to the old concept like we used for Apollo, where the tower is actually on top of the mobile launcher. This is all brand new hardware. Okay, it was built for the Constellation program. Hopefully we'll be able to use it for some commercial ventures or possibly some other vehicles that are developed by NASA. But the concept is to use the tower on top of the mobile launcher, so you have the rocket attached to it with all the umbilicas and all the lifelines, if you will, then we can take it out to what we call a clean pad concept. The pad, if you looked at pad B, you'll see there's no towers out there. It's a clean pad. You set the mobile launcher right on top of the pad, use it, bring it back here and build another rocket on top of it.
The shuttle mobile launch platform is just to the left between those two buildings.
That a flat one right now?
It's 9 million pounds, the driver says. On August 24th, 1972, Ron Evans, Gene Cernan, and I rode the crawler out to the launch pad. Believe me, it took a long time. I don't think we went all the way with it, but we went a long way with it. And we were about right here watching our vehicle come out, and then we jumped on the launch pad. Jumped on the mobile crawler.
See, it's jacked up here so that the crawler can go underneath it.
What's that?
Those pedestals are 22 feet high, and the crawler is about, the pedestals are 22 feet high. The crawler can go underneath that and jack itself up, pick that thing up. It can extend itself to 26 feet high. It's usually about 20 feet high normally, and there's about a 2-foot clearance. And there's some pegs that go down in the holes in the pedestals to hold in place, so it doesn't scoot.
If they look up underneath, you can see underneath you can see the channels for the various booster flames.
Over here was the platform you were talking about?
Yes, young man. How did I feel when I walked on the moon? I felt very privileged, as you might imagine. I was a lucky guy. I happened to get to the right place at the right time, presumably with the right skills, and able to be on that, what some of us have called the tip of the spear that 450,000 other Americans were holding. They made it happen. We just happened to be at the tip of the whole thing. It was a wonderful experience. I recommend it highly. Way back there.
From your point of view, who was the last person to walk on space?
Gene Cernan walked on the moon. He had to, because of the design of the hatch, I had to get in first. But on the other hand, I was the 12th person to step on the moon. So you take your pick. Neil Armstrong was first, I was 12th.
We vote for you.
Okay, yes sir.
And speaking of that, as the Apollo program was winding down, was there a lot of vying and maneuvering to try to you made sure you were on one of those missions? Was there a lot of competition on that? How did the politics of that end up working?
The question was near the end of the Apollo program. I'll just add any time in any program was there competition for flight. At least during Apollo, Deke Slayton was the boss. He eventually flew. He was one of the original 7 astronauts. He eventually flew on the Apollo Soyuz mission. He had been sidelined because of a presumed heart murmur, which nobody could ever find, but it kept him out of flight status for a decade at least. Deke, though, kept those cars very close to his vest. Everybody knew that they better perform well or they were not going to be signed, and don't do something to get you on Deke's blacklist. And it happened to a couple people. But it was mainly a competition of professionals knowing they better do things, whatever job they were assigned to, they better do it well. That was the best ticket they could have to get on a flight. Now, I was a bit of an exception. I think I did all of that. In fact, if you read Deke's book, and he agrees that I was capable as any pilot to fly the lunar module. I had been assigned to the backup crew of Apollo 15 with Dick Gordon and Vance Brand, who are on 2 other buses here. And about halfway through the training, everybody finally realized that the mission we would have cycled to, Apollo 18, was not going to happen. That had been canceled. Actually, it had been canceled long before. We just didn't know it, and effectively canceled. And so then it became a question of whether we would be in a position to replace Gene Cernan and his crew, who had been backup crew on Apollo 14. If we had demonstrated that we were good enough, better than they, and should fly Apollo 18. So we worked very hard, again, competitively, to try to convince Deke that we were the best crew. There were other things going on at NASA headquarters, and when Deke Slayton finally sent up his recommendation for the Apollo 17 crew, which was indeed to have Cernan, Evans, and Ingle fly Apollo 17. Headquarters, particularly George Low, I think, and said, no, we need to put a scientist on the moon, and you figure out how to do it. And so Deke had a choice. He could take the Dick Gordon's crew and substitute it for Cernan's, or he could put me and substitute for Ingle, and it was that choice, the latter choice, that he decided to do. And so that's how I ended up on the Apollo 17 mission. Meanwhile, of course, I had become a jet pilot and a helicopter pilot and everything necessary, and worked essentially every mission except Apollo 16. I was in the middle of Apollo 17 training during the 16 cycle, so I didn't do a lot with that, other than I had organized the Lunar Science Training Program for all the Apollo crews, and actually Jim Lovell's crew was the first one to really participate in that comprehensive science training program, which meant that about 1 week out of every month, these guys were out in the field actually doing exploration simulations, but on real geological problems. So that was the basis of that training effort. Yes?
Were you surprised with any of the geology you found on the moon?
Was I surprised by any of the geology? Well, yeah, continually surprised. Even though 5 other crews had been there, and I had spent a lot of time with them and with the samples they brought back and their observations. I guess we're headed into the Saturn facility. By the way, over those trees is the shuttle runway. I don't know, we're probably not going to get a chance to see that. No, I see a head shake. I think there were many surprises, but the biggest surprise was my discovery of these volcanic deposits that became known as the orange soil. They're actually orange glass, volcanic glass, that have continued to surprise everyone. They appear to have come from very deep within the moon. They brought a variety of volatile elements up to the surface, which nobody has expected to see based on the consensus ideas about the origin of the moon. And just recently, just published a few weeks ago, a paper came out that shows that there's water in that glass, significant water in that glass. So nobody expected to see water from the interior of the moon either. So it has turned out to be probably the critical sample in ultimately determining the origin of the moon based on the samples we have today. Now, if we go back, as I think we should, for geopolitical reasons, we can also do a lot more science, and we may get more information, particularly from those types of rocks and samples.
What would you call that again? Orange rocks?
Well, it became known as the orange soil because that's what I called it, because I didn't know it was glass. It was very, very fine, extremely fine dust-like material, but when you put it under a microscope, you find out they're little tiny spheres of glass. But it was, the size was something you couldn't see with the naked eye. It just looked like orange dust. Okay, are we getting out here?
I think we're going to get out here, sir.
Before we get off the bus, let's give a great big hand to Harrison Smith, folks. And let's give a great big hand for Chris Comerford, too, from NASA. and for Billy. And our driver right here, Kurt. Okay. Well, ladies and gentlemen, we're going to kind of get into line here. There's going to be somebody here in a moment to get us off the bus. And we're going to go inside the building and go to a panel operation inside here. And so just stay loose for a few minutes until we get over. You have a question, sir?
Yeah, we can leave the bags.
Oh, no, take everything with you. Don't leave anything on this bus. Because if you leave it on the bus, I'm in big trouble. I don't want to get in trouble with anybody. Yes, ma'am.
Can I ask you a question?
Yeah, go ahead, sir. I'm sorry. While we're waiting, go ahead.
I was just curious what your thesis and dissertation subjects were.
Oh, and she's curious about my PhD thesis and dissertation at Harvard. It had to do with some very unusual rocks in Norway. I was a Fulbright student in Norway, and then a couple years later I went back and did field work in western Norway. And these were rocks that formed at very high pressure and temperature deep within the earth. They're called eclogites. And in some places they're associated with diamonds. So you can see how high those pressures get to be.
We'll go ahead and
Okay.
record now.
Ready?
I guess you're about the only person around that doesn't have TV coverage of the scene.
That's all right, I don't mind a bit.
They've got the flag up now, and you can see the stars and stripes on the lunar
Flag
surface.
up now, you can see the stars and
Are you getting a TV picture now, Houston? Neil, yes, we are getting a TV picture. You're in our field of view now.
That's one small step for man, one giant leap